again to Labversity. In this session, we are going to discuss about the trigonometric ratios. In the previous section, we discussed about Pythagoras theorem. In this session, we are going to discuss about trigonometric ratios. Let's consider a triangle which is an equilateral triangle. Equilateral triangle means all its sides are equal and all its angles are equal. When 180 is divided into three equal parts, 60, 60 and 60. All sides equal. Let's assume that this is BC. The length BC is 2A. Then AC will be automatically also 2A and AB will be also 2A. Now what we are doing? We are drawing a perpendicular bisector. What bisector will do? It will divide this line into two equal parts, that this length will also become A and this length will also become A, and the 60 angle will be divided into 30 and 30. That means we are having in this equilateral triangle, we are having a right angle triangle on which trigonometric ratios can be studied and applied. B. I am saying this C prime because it is a part here, half midpoint of BC, C, and we are having A here. This is length 2A and this is length A, and this AC length is still unknown to us. How can we find this length? With the help of Pythagoras theorem. Now let's apply 2A, which is hypotenuse squared, is equals to A squared plus AC squared, which is unknown to us. 4A squared is equals to A squared plus AC squared. Now we have 4A squared minus A squared is equals to AC squared. 3A squared is equals to AC squared. Applying root on both sides, we will have under root 3A is equals to AC. Now what we are having, that this side of a triangle, a right angle triangle, is also known to us in the form of A. Now we have all the three sides in the form of A. 2A, A, under root 3A, and if we are considering this angle as our key angle 30 degree, now trigonometric ratios are sine theta, cos theta and tangent theta. They are the ratios of the length of the triangles which you are having. Now sine theta is composed of the ratio perpendicular and hypotenuse, the length of perpendicular and hypotenuse, and some people say it opposite and hypotenuse. Cos theta, base and hypotenuse, and cos adjacent upon hypotenuse, tangent perpendicular upon base, or tangent opposite upon adjacent. How to remember them? Good question. How to remember them? Some people remember them by a simple rhyme. Some people have curly brown hair through proper brushing, and those people who want opposite and adjacent, they say so, S-O-H, so, ka, C-A-H, ka, toa, T-O-A. You can remember them by soka toa, or some people have curly brown hair through proper brushing. Now, we will fill this table with the help of these trigonometric ratios, and you can check with your calculator. The calculator will be giving the same value. Sine theta, now I am writing sine 30 because we are going for 30. This triangle we are looking for 30. According to this triangle, if it is 30, then this side is called perpendicular for this particular data and this particular angle, hypotenuse, and this is adjacent or base. Some people have sine 30 perpendicular A, hypotenuse to A, 1 upon 2. Sine 30 is 1 upon 2. Cos 30 is base upon hypotenuse. The value of the base here is under root 3a upon hypotenuse is 2a. A will cancel a. We have under root 3 upon 2, under root 3 upon 2 as the value of cos 30. Now we are looking for tangent 30. If we are for tangent 30, in tangent we have perpendicular upon base. Here in this triangle our perpendicular is a and our base is under root 3a. A will cancel a, 1 upon under root 3, 1 upon under root 3. So now we have all the values of 30 for sine, cos and tangent. Now if we are to find same thing for 60 degree, only the angle will change, which means that this part 60 angle is to be considered and this is not to be considered now. According to this, our angle is 60, so it is no more adjacent, it becomes perpendicular or opposite, and this side becomes adjacent or base. Now same thing, sine 60 perpendicular. Now from this data our perpendicular is under root 3a and perpendicular upon hypotenuse, hypotenuse remain 2a. So under root 3 upon 2, under root 3 upon 2 cos 60, base or adjacent a upon hypotenuse 2a, 1 upon 2, 1 upon 2. Tangent 60 is perpendicular upon base, perpendicular under root 3a and cos 60. Cos 60 is perpendicular upon base. Our base is a under root 3. Now we are left with 45 only, but before we move to 45 angle, I will request you to observe this table, and in this table what can you see? The value of 30 sine is switching to cos 60 and the value of cos 30 is switching to cos 30. On the experimental basis, we tried with some of these values more. What conclusion we get? The conclusion we get is that cos 90 minus theta is always equals to sine theta. Cos 90 minus theta is always equals to sine theta, and sine 90 minus theta is always equals to cos theta. You can put different values of theta here and then see the result in your calculator. You are going to find this formula exactly correct. Now, how to calculate for the value of 45? This I am leaving for you, how to calculate the values of 45. I am giving you just only one hint. Before you are going to calculate this, draw an isosceles right angle triangle. Draw an isosceles right angle triangle. If these two sides are equal, that means perpendicular and base will be always equal, because this will be also 45, this will be also 45. What you have to do to fill these three things: number one, find the value of hypotenuse. Number two, say if base is A, The perpendicular will be also A in length, because perpendicular and base both are same. It is an isosceles right angle triangle. Now, if you use these trigonometric ratios, you can fill these 3 blocks. See you in the next session, and we will talk more about 45 angle and how did you fill it. We will also explain this. Thank you very much.